A surd is an expression containing a root symbol, such as a square root or a cube root. Here's an example: 7 square root 2. Now this means the 7 is multiplying the square root of 2. The square root of 2 can be typically 1.414, or we can have more decimal places if we so wish. Now whatever one we choose, it won't give us an accurate value of the square root of 2. So you end up with 7 multiplying, if you've got it in its decimal format, something that's not 100% accurate. So if it was 7 times 1.414, you're going to get a number, but that is actually not going to be the number. That is 7 times the square root of 2. It'll be an approximation to that. If you add more decimal numbers to the value that you decide to use, then this will become more accurate. A surd is used to represent irrational numbers with precision. So if you were to see this, you leave it like that. You don't bother changing the square root of 2 to 1.414 or the more accurate version of the square root of 2. Because if you use decimal format, you cannot make it precise. You leave it as the square root of 2. That gives you the highest level of precision. Let's consider 7 square root of 2. What we can do, we can write it as shown here. 7 times 1.414213. And this will give me an answer. Alternatively, I could have used this, where I multiply the 7 by 1.414 and I'll get an answer. Before I continue with the main flow of this video, let me draw your attention to this symbol here. It's the equal symbol in mathematics. Should I be using that here? Now, maybe pause the video and have a think about that. I'm saying that this is equal to this. Is that right? However, far better if you've got 7 square root of 2 is leave it like that. It's precise. Whereas if you use this approach, it's approximate, the answer you're going to get. Because if you see this number, you might forget that it was supposed to be the square root of 2. You multiply it by 7, you get something close to 7 times the square root of 2. Answers left in surd form are exact answers. So this is the exact answer, not this. Let's return to this slide, and I'm going to home in on this. Now, if you look, you can see this is 7 square root of 2 equals 7 times 1.414. Now, we know this is an approximation to the square root of 2. Consequently, if we consider this equal sign, it's not correct. We shouldn't really have an equal sign there. Instead, we should have this approximation sign, because this is precise and this is approximate. Now, going forward with your work on surds, I would take a good look at this slide and commit it to your mind's eye so you can see the exact difference between using surds and using decimal form approximations of things like the square root of 2. In other words, of irrational numbers. If you've got a root like the square root of 2, leave it like that. The advantage of leaving them as the square root of 2 and having these surds is if you've got a long calculation, you might come to a point where you notice that you have 2 square roots of 2, one as the numerator and one as a denominator, and they cancel out. Whereas if you were to have 1.414, you might start using your calculator to make the calculation. Whereas if you leave it as root 2, you can get to the end of your processing and suddenly realize you can start getting rid of some of the surds, and it makes life in the long term more efficient when you're doing calculations.